Hello everyone. Why buildings collapse? Top engineering mistakes which lead to the building's collapse. Mistake number 1. Poor soil investigation. Why? Why poor soil investigation? Because soil investigation is the primitive step in any construction activity. Now, let us delve deeply into the most crucial and critical topic of soil investigation and its key aspects. What is soil investigation or exploration? What it is and why it is a crucial aspect in civil engineering. Before conceptualizing any building or structure, the actual site for the proposed construction is the prime requirement. Once the construction site is finalized, the planning of the structure should be initiated. Also, conversely, the building can be conceptualized and the site can be selected depending on the building or structure details. Whatever the situation or condition, in either case, soil investigation or exploration is a very critical aspect. What is soil investigation? As the name indicates, it is the investigation of the soil and the subsurface strata where the building is anchored or supported upon and must be durable for its design life, which is basically 75 to 100 years RCC building life expectancy. Proper soil investigation will provide the data for the structural designer to design a durable, stable, and safe structure that will perform excellently beyond its expected life. Soil investigation encompasses a series of scientific and engineering studies aimed at understanding the subsurface conditions of a site. It is an essential precursor to construction, guiding decisions about foundation design, site suitability, and potential risks. In technical terms, site investigation refers to the systematic collection and analysis of geotechnical data to characterize subsurface materials and evaluate their suitability for supporting plant infrastructure. This includes studying soil and rock properties, groundwater conditions, and any potential geotechnical or environmental hazards. Site investigation is not merely a procedural requirement but a strategic necessity that informs critical decisions during the design and construction phases. By assessing subsurface conditions, geotechnical engineers, consultants, and contractors can mitigate risks, optimize construction methods, and ensure compliance with environmental standards. Soil investigation or exploration, why is it crucial? Foundation is the key to success and stability. The stronger the foundation, the deeper the success. Hence, buildings and structures standing on a strong foundation will stand longer and stronger. A strong foundation can only be constructed with proper subsurface data. This foundational step is encapsulated in the process of soil investigation, a systematic approach to understanding the physical, mechanical, and chemical properties of the ground. Hence, soil investigation or exploration is very crucial. The success of a construction project is heavily dependent on the quality of site investigation. This process is not just a preparatory step. It is a critical measure to ensure structural integrity, safety, and sustainability throughout the project life cycle. The absence of a thorough investigation can lead to unforeseen challenges such as foundation failure, increased costs, or even catastrophic structural collapses. Soil investigation exploration, why it is crucial. Let us understand the different aspects one by one in detail. Let us see all the aspects. First, number one, ensuring structural safety and stability. The primary purpose of site investigation is to ensure that the infrastructure can be safely supported by the underlying soil and rock. By analyzing factors such as soil stability, bearing capacity, and groundwater conditions, geotechnical engineers can design foundations and retaining systems that are resistant to settlement, landslides, or shear failure. Key considerations: soil bearing capacity. This defines the maximum load a soil layer can support without failure. Soil stability. Factors like cohesion, friction angle, and slope angles are assessed to prevent landslides and erosion. Seismic vulnerabilities. Site investigation should include seismic hazards assessments, especially in regions prone to earthquakes, to design structures that can withstand seismic forces. Site investigations today are more robust with technologies like geophysical surveys. Methods such as ground penetrating radar and seismic refraction help identify subsurface anomalies without intrusive methods. Remote sensing, satellite imagery and drones provide macroscopic views of the site, aiding in large-scale assessments. Geotechnical instruments, monitoring tools track soil and structural behavior over time, ensuring proactive management of risks. Cost, second point, cost effectiveness and risk mitigation. A thorough site investigation minimizes the risk of unexpected site conditions, which can significantly inflate project costs. For instance, encountering weak or unstable soil layers late in the construction process can necessitate costly redesigns or remedial measures such as ground improvement techniques. Examples of cost saving outcomes: optimized foundation design based on actual site conditions, reducing material overuse, early detection of high groundwater levels that may require dewatering systems, preventing delays during excavation. Identification of geotechnical hazards might have necessitated more expensive mitigation strategies during construction. Third, environmental sustainability. The process includes assessing the potential impact of the project on the surrounding ecosystem and identifying the environmental sensitive conditions such as soil contamination or the presence of aquifers, because aquifers are the dangerous natural available environmental condition. Key environmental factors: soil contamination analysis, identifying pollutants in the soil to ensure safe disposal or remediation. Groundwater analysis, understanding the aquifer system to avoid contamination and ensure proper drainage. Erosion control, proposing measures to prevent soil erosion during and after construction. Fourth factor. Number 4. Influencing long-term performance. Proper site investigation ensures the long-term performance of the structure by preventing foundation settlement, cracking, or other forms of structural degradation. This is especially vital for large-scale infrastructure projects where failures can have far-reaching consequences. Number 5. Case studies highlighting importance. Numerous high-profile cases underline the consequences of inadequate site investigation. Leaning Tower of Pisa. Historically, insufficient understanding of soil stratigraphy led to its iconic tilt due to differential settlement. Boston's Big Dig project. Delays and cost overruns were partially attributed to unforeseen geotechnical challenges, underscoring the importance of thorough site investigation. Now, number 5. Integration with modern engineering practices. Site investigations today are more robust with technologies such as geophysical surveys, methods such as ground penetrating radar and seismic refraction help identify subsurface anomalies without intrusive methods. Remote sensing. Satellite imagery and drones provide macroscopic views of the site, aiding larger scale assessments. Geotechnical instrumentation. Monitoring tools track soil and structural behavior over time, ensuring proactive risk management. This is the end of the presentation. What is covered above is only the synopsis of the geotechnical investigation. However, geotechnical investigation itself is a branch of civil engineering which is vast and has to be completely studied separately. But for a civil engineer, this serves as a guide live video for soil investigation. Thank you all. Thank you. Thank you. Please share, subscribe, like,